Well, okay, there's our first technical problem of the evening. It appears I've been talking to myself without unmuting my mic. Sorry about that, folks. So, welcome to our Night of Science Week talks. We're in conjunction with Young and Engineers Society and Engineers Ireland, and Science Week is 25 years old today. There's lots of events happening all over the country, and we're doing our part for science by having 3 talks here tonight. Our first talk will be about fungus underneath a kitchen table from Tríona. Our second talk will be about DIY solar install by Christian, and myself will be giving the third talk about an IoT weather station. So the format is we're going to go through each of the talks, and then we're going to have a Q&A at the end with each 3 speakers. If you have any questions for our speakers, please use the chat feature below, and we'll read them out to the speakers. So first up, we're going to have Tríona. So hopefully I successfully changed screen now. And okay, we have Tríona.
Okay. Good evening or good morning if you're up really early in a different time zone. I am going to talk to you today about some fungus that's grown under my kitchen table. So Jeff, wrote me into talking for Science Week, and I'm like, oh lads, what am I going to talk about? And he's like, well, you've been tweeting about these mushrooms under your kitchen table, so how about that? So, and if we're into tweeting, at Talk Dublin and hashtag Science Week is always fun. Okay, so you want to find out something about the mushrooms under my table. So I'm on Twitter. You can tell from the hashtags and the username at the beginning. So Ballyhooer mushroom, if you don't follow them, are great. They're into mushrooms. They grow mushrooms. They do mushrooms in the local milk market on a Saturday morning, and they sell really fancy, like really fancy mushrooms. And so this tweet came past me, and I'm like, oh wow, grow my own mushrooms. I don't have to go to the milk market anymore. This is pretty interesting. So I DM them, sent them some money because I've tried it before. So the first time I tried it, I got a kit from Aldi. You can see the charming photograph on the right of a couple of giant mushrooms and very little else happening. The second time, it's not been pictured, but I effectively ended up with a box that smelled of wee and sort of horrible stringy mushrooms that didn't grow all that well. But I'm a champion. I dusted myself down of compost and tried again. So I sent Ballyhore Mushrooms some money. I gave them my address, and they sent me a box of wood shavings and mushroom spores and some instructions. So really easy. Cut the little X's in the side of the bag. Spritz it every day, which I must remember to go and babysit it now. Actually, once we're finished here, and mushrooms are supposed to happen. So it's like, okay, that's interesting enough. What sort of mushrooms are they? These are grey oyster mushrooms, Pleurotus pulmonarius. So for those of you who are educated in the ways of Latin, I believe Pleurotus means something like sideways, and pulmonarius means lungs. These mushrooms that Irish shiitake, which is Ballyhooer Mushrooms handle, posted, look nothing like lungs, but I'm not going to argue with them. It is a mushroom type that's native to Ireland, grows on birch trees and beech trees, and it lives off dead wood. So, thing about oyster mushrooms is there's different types of oyster mushrooms. So this isn't oyster mushrooms, the canonical pure type species of oyster mushrooms, which is Pleurotus austriatus, which does mean oyster, sideways oyster. But it's a kind of more common variety across colder parts of the world. Um, Incidentally, the actual oyster mushroom is not allowed into New Zealand. So the same way they're keeping COVID out, they are keeping Pleurotus austriatus out, but they'll let you grow oyster mushrooms, no bother. So my kitchen table would be welcome in New Zealand. All right, so I did promise you guys some excitement. You want to find out about mushrooms? Let's find out about mushrooms. So one of the cool things I discovered was eat nematodes. And I'm going, holy, what? They're carnivorous? So mushrooms aren't really plants. They're kind of closer to the animal kingdom, but they behave much more like plants, but they don't really go anywhere very fast. And so it turns out oyster mushrooms, so some of the subspecies actually secrete toxins, immobilize the nematodes, send hyphae into the nematode openings, digests this immobilized but live nematode inside out. And I'm like, all right, that's deadly. That's pretty cool. But maybe you're not all up for that level of excitement. So one of the other ones that I came across that was particularly interesting is oyster mushrooms as a food intake suppressing substance. So this group of researchers in Japan took oyster mushrooms and a bunch of other edible mushrooms, dried them up, ground them down, put them into the rat food. And the rats refused to eat food containing oyster mushrooms or oyster mushroom extract, even when they were emaciated. So these rats are in a bad state and they're still not touching mushrooms. And it appears to be due to a lectin, so POL, which is Pleurotus austriatus lectin. And it seems to find things in the mouth of the rat that they're not happy about. So I just wanted an excuse to mention lectins. I spend a lot of my research actually working with lectins and recombinant lectins and stuff like that. Lectins are simply proteins that bind to sugar. They're super important for cell signaling, super important for anchoring. It's how your cells kind of know to stick to each other and move about. Some of them are really interesting toxins. For those of you who watched Breaking Bad back in the past, ricin is a great example of a lectin my PI used to always give out to me, going, "Stop telling people these are dangerous." I'm like, well, only some of them are. So anyway, lectins, they're really cool. And in fact, another mushroom lectin was discovered to make vaccines much better in mice. And I go, wow, this is also another COVID related topic. How can you make vaccines better? And so it appears that if you take certain mushroom lectins and when you're adding it into the vaccination, it actually activates additional immune response. So it's what's called an adjuvant. And you end up in this sort of situation where you get this enhanced immune response due to the lectin. And because your immune system's turned on, it's now more willing to pick up the actual DNA of the vaccine itself that's interesting. So, lectins, they're super cool. Now, maybe that was way too exciting. So, the other thing I rolled across today that I found terribly exciting was drying mushrooms using ultrasound. So, you could dry mushrooms at really low temperature. And of all of the research I've been reading through today, I had exactly one color photograph to pull out and show to you. And you can just see that, the structure of the mushroom is like there's less damage done to it once you try it using ultrasonic. So, okay, why do we care about dry mushrooms at low temperature, Tríona? Like, that's probably too unexciting for us. Because you want to conserve nutrients. And one of the interesting nutrients in mushrooms is ergosterol. And ergosterol is a precursor to vitamin D, which is the permanently fashionable vitamin. Main sources of vitamin D are sunlight and dairy. It's great for bones, it's great for depression, it's great for your immune system. It kills cancer in mice, it kills cancer in petri dishes. Vitamin D, absolutely magic. And it is found in mushrooms. And it's especially found in mushrooms that are grown in sunlight or under ultraviolet light, which helps the mushroom convert the precursor to vitamin D2. So, good news for any vegans living in a high latitude where you don't get enough sunlight. Eating some more mushrooms probably wouldn't be a bad move. Now, of course, if we get back to my time growing mushrooms, one of the other things that came up was the smell of wee. And I ended up reading a lot about bioremediation and how mushrooms really break stuff down in their surroundings. And the absolute stink of wee from that box of mushrooms was due to the mushrooms breaking down excess protein around them, releasing ammonia. Now, ammonia is toxic to the mycelia, so the kind of root structure of the mushrooms. So that would probably explain why I wasn't so successful the last time I was growing mushrooms, because basically I poisoned them with ammonia and my garage because it stank. Okay, so how did it work out this time? Very successful. So I got really lush growth of these mushrooms. I grew them under the kitchen table with some light. There may have been vitamin D in these before I cooked them, but super exciting. Really proud of myself. This was the first time a mushroom kit worked really well. Didn't quite match these beautiful, tall, elegant mushrooms, but did match the type species a bit better for the actual oyster mushrooms. So the next thing I did was I dried them. I did it in an oven, so we would have probably lost some nutrition. Fried the rest in butter, definitely lost some nutrition. Vitamin D in butter probably doesn't matter once I cooked it. and I made a risotto. And I don't like mushrooms. So I ate half of the risotto and gave the rest of it to my other half. So I'm with those rats in the study in Japan. Mushrooms, not delicious. So thank you very much for listening. I did try to find a thank you slide with an oyster mushroom on it, but the world is into more photogenic mushrooms. So with that, thank you very much. And questions are going to come at the end. So let me know then if there's anything I can answer. And thanks for listening. Happy Science Week.
Thanks very much, Tríona. It was very interesting to hear all about the mushrooms, and it's a bit of a shame that you don't like them. You don't like them yourself. So, remember, if you've got any questions for Tríona, stick it down in the live chat, and she'll be back in no time at the end of the session. So up next, we have a talk from Christian about a DIY solar install.
Hi, my name's Christian Kortenhorst, and I'm a member of TOG for the last few years. I started this project around 2-3 months ago, in relation to trying to reduce the amount of power that our office was using. So I started looking into what was using the power and how much power we were using, using a cheap power meter. Then I started looking into offsetting the power against what we were using, maybe using sun, or so I looked into solar panels and started to get quotes from companies, and it just seemed very difficult to get anybody that wanted to do it, or they were too busy, or so, and the cost was predominantly quite expensive. So I thought, let's try do it ourselves. So I'm no way an expert in this area, but I've certainly learned a lot over the last few months, and it's working well for us, and it's definitely I'd recommend it to anybody that's thinking about doing it, to go the DIY route. So you need a number of things. So firstly, because we were on a commercial roof and we needed a cherry picker and the likes, we got a roofer who had done some work on our roof before to install them. He'd never installed them before himself, but he had a bit of cop on, and he kind of understood it, and the manuals were very easy to follow. And then our electrician obviously understood it, how it worked, and we had a number of tutorials on how to do it, from the crowd who we bought the kit from, and then the solar hardware you need. And then one thing that wasn't supplied and we kind of had looked at was monitoring of all of this. So we opted for a Shelly 3EM, of which I'll go into more detail in a bit, how it works and how we pulled out the monitoring of the power from solar panel and the general usage that we were using. It's I really recommend it for anybody. Now this is a 3-phase version, but they also do single phase, and I'm pretty sure it can be configured to monitor different, not phases, but different inputs on your board. So I've broken this down into pretty much 4 different sections. So you've obviously the array that's on our roof. We went with 12 panels, which is 4.7 kilowatts. Then top right hand corner there, you've a fireman switch. So that's cut off, so that if power gets cut to your building, the power that's generated from the solar panels cuts off any input to your board or back onto the ESB, so that in the case of anything going wrong, somebody working out on the line on the road doesn't get electrocuted. And then you've got the inverter and isolator switches from the panels on the roof, and then bottom left hand corner is where it's plugged into the actual board. So how because we have a 3-phase system, it's slightly more expensive to run, to buy the kit, and it's a bit more expensive to install also. So but as a whole, it's pretty straightforward. So we've 3 breakers there, of which is the output from our 3-phase inverter, and that then feeds 1, 2, and 3 into the board down there at number 7. So it's literally from the inverter into the board, so then this is our setup here. So you've got the inverter that does the conversion from DC to AC, and takes direct current obviously from, and then converts the 240 volts from the roof into AC power, and then splits it over the phases. And we have 2 arrays that I'll go into a bit more detail on. But the fireman switch, as I discussed, that's the cut-off switch, that's the green box there. That has to have permanent power from your board. So again, if that goes off, nothing works, and it's a safety mechanism. And then you've got obviously your DC isolator and your AC isolators. So then we've got our panels on our roof. So we have an insulated Kingspan roof, so very easy to install. Some tech screws into the tops of the roof, and it literally 2 hours and all the panels were installed. It was actually the electronics that took a little bit longer to install, but once it was installed, the guys flew it up, and then we drilled a hole through the roof and sealed it off. And again, the roofers did all of this. They were very skilled guys. So we have a 6x2 array. So the reason we did that was, if you've any form of shading or bird poop or anything on one of the panels, you get an effect on across all the array, each panel. So if you've any form of shading, you definitely split them. So we had 4 cables going to the roof, the input and output. So we call them array 1 and array 2. So that's the top set of panels, and then the bottom set of panels. And then so if we do have any issues, then we can isolate an array. So this is the output of the power that we get. So top right hand corner there is the Shelly unit that we get. So that's our usage throughout the day. I think that's a month or weekly view there. So obviously they're A, B, and C phases. You won't have that in a home setup, but we do in the office, and then the total usage throughout. And then on the left hand side there is the output of the data logger. It's a little dongle that goes into the inverter, connects to your Wi-Fi, and that also logs up to a website. It's quite interesting to see. So our max power that we're getting out of the 4.7 kilowatts, I'll explain this a bit further, or my theory of why we're getting so little out of the 4 is 3.5. So firstly, we only set this up in the last 2 months or so. Our angle is not really the optimum on the roof. It's only 10 degrees, and it should be more like 30 degrees. Our max power daily that we've generated so far is around 16 kilowatts. But that could be anything as low as 2 or 3, depending on the day, if it's raining all day or it's cloudy. So it still does generate stuff, but it's our average usage in our office around 30 kilowatts. And we've around half a kilowatt that we use without anything going on. So that means we still have on the weekends and stuff, we still have some usage, but that's cancelled out by the solar normally. So what we're finding is winter months, certainly these months, we're getting probably a tenth of what we got Now certainly the panels themselves aren't at the right angle and stuff, so we're looking into what we do with those, or even just adding more panels. So then as for the costs of the overall system, so this is what we ended up spending. So the electrician, plus a few bits of hardware that he had to supply, so trip switches into the board, and the spur power for the fireman switch, we spent €400. The roofer was €500. That included the cherry picker, and the solar panels themselves was a kit supplied by Solar City. So they're a crowd up on the north side. Really good to deal with. Send them a photo of your roof, tell them what you want to get, and they'll send you back exactly a kit, what you need to buy, and it's really good service. So what it looks like is we're saving around €150 a month on our bill. So, and that's without the buyback into the grid. We've yet to kind of, I think next June is the next time so there'll be a payback into the grid. But I'll talk about some other systems that we're looking at doing ourselves, because the payback will be nominal. I think it's 16 cents a kilowatt now, and you might be paid 2 or 3 cents, so it doesn't really make sense to put it back into the grid. So then that's where batteries and things come into play. So we estimate 2 to 3 years, but again, I'll only know kind of this time next year, when we've been running for a year, what's our savings. I mean, at the moment, certainly on a sunny day between 9 and 5 when we're in the office, our meter doesn't move as such, so it's pretty good in that sense. It's the after hour stuff or days that it's just not. Yeah, and then as I mentioned before, the estimates are just very expensive from third parties, because I feel that the grants and things out of which we don't get for being a business kind of didn't make sense. So then future plans, so looking at adding 6 more panels. So this is a kind of a trade-off. We can add 6 more panels, because the second point there about mounting panels, what angle do you raise up the angle of the panels and try to get more efficiency out of your panels, or because the panels are so cheap nowadays, do you just add more panels? For I think it's €100 a panel, and a bit of time for the roofer. You can just very much, and you just click them into the next one. So we'll have a 12 array, and then we'll have a 6 array. So we'll end up having 18 panels on a roof. So then I'd also like to monitor the panels. So I know the inverter has its own monitoring, but if we could monitor each individual panel, or monitor the output on the same Shelly system, then you could overlay kind of what's being used and and really monitor it. So then I mentioned this before, the excess power, so that you can dump into your immersion. So because we're a 3-phase system, what we can find is there's one phase is using 2 kilowatts, and another 2 other phases are using half a kilowatt. So because how the inverter splits the 3 kilowatts that you get off the roof into 1, 1, and 1, you could be feeding back on two of the phases back to ESB, whereas realistically you should be dumping that back into, and hot water seems to be the kind of the best way of doing it, and then modifying the angle. So yeah, a few more ideas on what we do. So then as for that, any questions, or let me know, and I'm always available to receive any emails or calls if you have any questions. I'm no means an expert, but I've certainly learned a good bit over the last few months installing it and managing it. It's been interesting.
Thanks very much, Christian. It was a very interesting talk. I'm sure it'll be interesting to some of our young engineers who have tuned in tonight. It's good to see what sort of aspects can be done with an older building. And it's not just all about these passive homes and brand new builds. That a lot can be done with older units as such. So if you have any questions for Christian or anything about the solar cells, be sure to stick them down in the comments below, and Christian will be joining us now for a live chat just after our last speaker of the evening. So up next we have myself talking about my IoT weather station, and we'll kick it off right now. Hello and welcome to my talk on building an IoT weather station. My name is Jeffrey Rowe. I'm a member here in TUG and also involved with the Young Engineers Society in Engineers Ireland. So one of the problems we face is there are only 26 Met-Éireann weather stations, and more importantly, there isn't one in my back garden. So I was really interested during the first lockdown as to where I could pull local data from, and if possible, create that data myself. So after searching around the internet and going over various different kits, I came across this one from DF Robot, which had a nice happy medium where they provide the hardware and a basic controller, and you had to write the software. So it's very different from the commercially available units where it's a sealed unit, the data gets uploaded to some proprietary website, and you either have to pay or have very limited access to the data. I wanted to build all the software myself and have access to the raw data. So in this particular kit, it has units to measure wind speed, wind direction, it has a rain bucket, you can pick up the temperature, the humidity, the atmospheric pressure, and then all that's pulled together in a sensor board. So here on the website yesterday, it costs $138. I think I got mine for about $120 plus shipping at the time. So I ordered that during the first lockdown, but due to this crazy situation and no flights and disruptions in the whole supply chain, I ended up didn't get it until very much late summer. So here are all the parts on my desk. You can see it all goes together with screws and bolts. Even without instructions, it was pretty straightforward to put together. Most things were keyed, so you can only put them in one way. The units themselves are kind of fairly robust plastic. It all goes together on a kind of stainless steel tube, and some of the wires are daisy chains, and it's very easy kind of snap together sort of construction. So it only took about a half an hour to pull all that together, and next it was to look at some software, how to get the data and how to interact with it. So the board on the left is what comes with the weather station. So it has old style telephone connectors up at the top that pulls in the data from the sensors, and then on the board itself it has its temperature sensor, humidity sensor, and air pressure. It takes in 5 volts to power it, but unfortunately it has no communication, wireless communication on board. So there's no way to get the data to the internet on that board alone. It will just spit out the data over serial. So that's where the board on the right comes in. It's a Node MCU. It's a cheap $3 board that allows us to upload the data to the internet and do all sorts of the communication. But the board on the left uses 5 volt logic, and the Node MCU on the right uses 3.3 volt logic. Unfortunately, those two don't mix, and that's why we have the device in the middle, which is a logic level shifter. So it will do the shifting between 3 volts and 5 volts. It's bi-directional, so that way we can have a great serial link between the two devices to exchange the information, and we have a great board where we can write it in the Android and the Arduino development environment and be able to get our data to the internet. So next up was dealing with the software. So the first thing I did was downloaded the example provided on the manufacturing website. So that provided a method to pull all the data that comes in over a serial link and then print it to the screen. So on the screen on the right, you can see the wind direction, average wind speed, max wind speed, the rainfall, and all the other stuff that comes from the weather station itself. So remember, the board on the left sends all this data over to our Node MCU, and we're printing it out here on the screen. It takes data readings every minute. So the first thing I did to modify the sample code was to add over-the-air updates functionality. So this would allow me, when the device is installed outside, that if I need to do a software change, all I have to do is take out my laptop, connect to the same Wi-Fi network, and wirelessly update any software that's running on my weather station. I don't have to go and take it down, pull out a USB cable, try and connect it into the microcontroller. It's all done over the air wirelessly. Then the next step was getting the data to the internet. So I use this platform called OpenSenseMap. I use it for another project in measuring air quality, so I was quite familiar with it. It allows you to upload all sorts of sensor data to their website through an easy-to-use API. It's all free. You can download your data at any time in CSV file format. It allows you then to share the data with anyone in the world. It has a great web interface where you can click, look at your data, and there's plenty of apps that pull data from this particular source, so you can then view it on your phone nice and easy. So I upload to this website once a minute because I don't want to overload the website with too much nonsense data. There's no real point in checking the temperature every second. Every minute is just fine enough. So that was all the coding done. Next step came to the installation. So I'm not very good at DIY or hardware, that sort of hardware myself, so I got my brother to help me out. So we have an old extension at the back of our house. So on that wall we put up a wooden plate and then a wooden pole. So on the plate there, on the photo on the right, you can see waterproof kind of electrical junction boxes, and that's where I put all my weather station boards that I talked about before. And on the left, I decided to install air quality monitoring station while I was at it. So it gets power through a USB cable fed through the vent on the other side, on the other wall, and that's fed around into the unit, and then it has cables going up the wooden pole into the weather sensors themselves. So here is a photo of it all installed. It's nice sunny weather. There's absolutely no wind, so it's hard to tell if the software or anything is working. So the next step was to take out my laptop and look at the data that was going to the internet. So it went well initially, but then I started noticing some strange things. Stuff like getting 600% humidity, getting 2000 meters per second wind speed, and it was a perfectly sunny day outside. Something really didn't add up. I was noticing different between the test on my workbench and when I installed it is I was getting a lot of weird values. So after some digging around, it turned out to be noise on the serial link between the weather station board and the Node MCU board that was throwing in random characters into my serial message and totally messing up all my values. So what I ended up doing excuse me, is writing a little method there that checks the data, it checks the right prefix on the message, and if there's any bad or crazy values like humidity over 100%, things like that, then I disregard that message. So these messages, as I said, come in once a second, but we only upload to the cloud once a minute. So it's fine just to disregard one of these samples if I end up getting bad data. Unfortunately, because the weather station board is essentially like a black box, and the manufacturer doesn't supply you with the source code, you can't really use any more advanced features like forward error correction or checksum to better check the data. And the only solution in the end I found was either to write the whole weather station software from scratch or just disregard the sample of data. And because we're getting 60 samples before we're uploading, there's plenty of data around just to disregard a bad sample or two and then just only upload the good samples. So now on your screen, you are seeing the weather station in action. It was a few days later, the wind had picked up. Sorry for the kind of wind noise, I didn't really cover the microphone. It's just to give you an idea of what's it like up there. So the weather station is going away, the wind's blowing. But what you might have noticed in the video is there's a large wall right behind it. Unfortunately, I live in a terraced house, and one whole side of the street is blocked from all the houses. And because it was only getting started in this whole area of weather stations, I didn't really feel right to stick the whole unit on the second story kind of chimney and just to leave it up there. I kind of wanted to bed it in, see if the hardware worked, see if my software worked, and then maybe in the future I might move it up to the top of the roof so we get better values. So one wind direction isn't totally blocked out from the unit. My back garden is too small to move the unit further back. We'd still be blocked from one side of all the houses. It's a bit of a kind of an urban canyon in these row of old houses. So maybe in the future I might put it up on top of the chimney and then get a more accurate full aspect of wind from all directions and able to get it a bit of better value and not have the houses interact with it. So if we jump back to the slides, we come to our end, which is some important links to give and some reflections on the projects. So as I said, a better location will give me a bit more accurate data, not being blocked by one side of the house. There's a big problem with where the temperature sensor is housed. It's in a plastic box. It doesn't really get the air. It's very sheltered. So although the temperature sensor might say it's 15 degrees outside, when you go outside it definitely feels colder. So it maybe need a better Stevenson screen to house the temperature, humidity sensor and air pressure sensor, so it's get a better real air temperature at what it is outside and not what it is in the plastic waterproof box. One of the other aspects that should be fixed is the coding itself. It uses a hard-coded SSL cert that has to be updated every 3 months. Otherwise, you can't post the data securely online. So that should be fixed. And also look at maybe getting better sensors and look at more robust or more, maybe look at calibrated sensors would be a good approach to go. So I have some links here on the screen. One is to a more detailed write-up on the TOG website. The other one is to, if you want to check out what the weather is in Crumlin anytime, you can click on that link on OpenSenseMap and see what the weather's like in my back garden. And then also there is my Twitter handle, Jeffrey_Rowe, if you want to follow along on any projects that I might be up to in the future. So now for our Q&A session. We have all our speakers present. I hope you've all put in your questions. There's still time to throw in a question. So I will kick things off. Tríona, we have to know, are there mushrooms all over your kitchen now?
No, they're still safely contained in the box underneath the table. But they are kind of dripping white spores all around the kitchen. Not the kitchen itself, but inside the box. But it is not going anywhere else for the time being.
And what does your kitchen smell like now? Is it?
Does not smell of wee. Very important to note. No smell of wee. What does it smell like at the moment? Probably smells like onions because dinner should be started by now. But the mushrooms aren't stinking the place up actually. It's been nice. It's like having a little pet that, just doesn't do much other than grow.
All right, and we have a question now for Christian. How much research did you put in before starting this project? Were you months at it? Did you have a background in this sort of stuff?
No, I spoke to 2 members in TOG who had looked at it before. And then I rang the Solar City crowd. And I asked them for some advice, and they said most of their kind of installers and stuff were busy. So then I just ordered everything, and that was it. So it's a pretty spur of the moment decision to make. But no, I kind of knew the efficiencies. I've done a lot more research after buying this stuff. than
You're trying to avoid that
join
buyer's
the Facebook
remorse.
group. Yeah, exactly. So, but no, and I kind of knew the maths. Even I had always kind of thought maybe we might get 50% out of the panels, and we're getting a bit more than that. But today now and winter months, I don't expect to get much. So I suppose I'll have a lot more in a year's time, But even if the payback, even if I doubled the payback from 3 years or say 2 years to 4 years, the panels are meant to have a 30-year lifespan, and the inverter is a 10-year lifespan. So, or like even the warranty on them, even. So, yeah, it made no, or it was kind of very easy to make that decision. And the panels are so efficient now, and I didn't think that would change much. So, yeah, we've just ordered the 6 more panels, and we're going to try raise them up to a different angle, and then see does it make sense to spend money on raising the other panels or not. So,
Okay. And the
but no,
next
very little research.
Okay, and the next question is for myself. What causes the noise, and can it be fixed by hardware? So, the noise was introduced after I moved it from my workbench over to the live install. The length of the wires got much longer compared to my test setup. The components were much more in a confined space than on my test setup. They're in a much more confined box. So the normal operation of the sensor board could introduce noise into the wires going between each unit. More could be done with shielding, could be better used. A different type of serial protocol where you have more shielded, and different serial methods will provide are much more noise resistance. So there are things that can be done in hardware, but because it was already installed, I tried to approach it just with software and trying to fix hardware problems with just a software update. Okay, next question is for Tríona. What do you do with this mound of stuff after you're finished growing your mushrooms?
Oh, so that's going to be really easy. So I am planning to throw it into the garden. So it basically, the mushrooms make really good compost out of the bits of wood and wood chippings and straw and all the kind of stuff that's in the bag. So the plan is cut the bag open, discard the bag in an eco-friendly way, and grow things that are more delicious than mushrooms with the resulting compost.
Okay. And the next
Anything
question
but
here
mushrooms.
is for Christian. So you install these panels in your office in a commercial unit. What would the differences between when you install them in a household?
So yeah, that's my next project is our house. We're actually building a house. So I see the benefit a lot more in a house. The only thing is the roofing is going to be a lot more tricky because it's not just you've got to cut the slates, and there's a bit more involved in installing them. So we're going for similar size array in our house, and but the advantage is if you're generating 3 kilowatts, you're getting 3 kilowatts also into your board. You're not splitting it, and the feedback, and also there's a device called a solar boost, and that allows you to put a clamp meter on the feedback into the meter, and that automatically turns on your immersion and dumps the excess power in. So there's a few things. But our big advantage of being in the office is we're using the power 9 to 5, so we've no need for a battery, and pretty much on a sunny day, our meter wouldn't move between the hours of 9 to 5, on a summer day now. So I think that the roofing is going to cost a bit more, but the inverter is 20-30% cheaper, because it's not 3 phase, and the solar panels are the same, but you're getting a lot more out of it. So,
Okay.
but the Solar City I couldn't recommend highly enough. Like I know there's 2 or 3 other guys out there that are just supplying, but all the warranty and stuff is from them, and I've not had any bother. They just ship it on a pallet, and you literally take a photo of your roof, and they'll send it to you. And a good roofer, good electrician, and just reading their manual kind of was enough to install it.
Okay, next question here is from Brian. He wants to know the weather data that's stored on OpenSense map, can it be used to assist or correct the data from the air quality sensor? So the units are quite close to each other. At the moment there's no automated way to adjust or use data from one to the other. Fog has a real impact on the air quality sensor, that it just goes haywire, and the way the laser centering, the laser light going through the sample works on the air quality sensor really has a big impact when there's fog, and it kind of craps out. So yeah, it would be useful to combine both data together, but I don't have an automated way to do that, and I think I'd do a lot more study in environmental engineering to be able to rightly qualify on that one. Okay, so we have another question for Tríona here is, can you grow anything else underneath your kitchen table?
I'm growing quite large dust bunnies at the moment. I think mushrooms are pretty good because they don't need much light, but if you had anything else, like edible plants really like a lot of light, so your herb garden does need to live in a window. So mushrooms and dust bunnies would be my main recommendation for things to keep under your kitchen table.
Okay. All right, we have another question here. I'm not sure which talk it applies to. How are the ones you get from AliExpress? Would you recommend, or the guys from the north seem to have better quality? So I'll answer this one first, and then maybe Christian will answer it in case it's about solar panels. All the parts I showed you, I did order from AliExpress. Unfortunately, they took, during the lockdown, up to 3.5 months to get here. I was losing hope by the end of it. But usually, in non-pandemic times, stuff ordered from AliExpress seems to be reasonable. You do have to check for, if things are too cheap, then there's probably a reason for that. But general components and Wi-Fi boards are fine. Okay, so we have an update. It's actually about the solar panels. So I'll throw that question back over to Christian. What do you think about ordering them directly from China or from the north, or different suppliers?
Yeah, the only reason was that it was it's a large enough purchase that if I can go to a local company, and like literally I order stuff on a Wednesday, it arrived on a Friday, and yeah, so it was that backup support. I've looked at wind turbines, because that seems to be kind of a constant, but then they need a lot more maintenance. So whereas the solar panels are, washed once a year, and so yeah, I just went for the support. It was, could you save 20-30%? But then import duty, like like they're large units. They're 1.7 meters by 450. So they're they're size of a person with their hands out. So it'll be a few pallets worth of gear to come. So yeah, I just looked for the support. That was all. I didn't really look around in the sense of so yeah, it was too large of a purchase to chance it on AliExpress.
Okay, that brings an end to all our questions. I want to thank Christian and Tríona again for giving talks tonight.
Oh, there's one more there about batteries, actually.
Go for it.
So I did look at batteries, but the battery technology seems to still be developing so much, and because we're using all our power, the generated power during the day, it just didn't make sense, and the pricing is still not there. Like you can buy a 2 kilowatt battery from multiple suppliers, and it's around €1,000. But if you look at our usage with our lights on, 2 kilowatts you'd burn through in an hour. So it just didn't make sense. Yeah. So whereas if you look at the pricing in the US, where the market's much bigger, they really the price for 2 kilowatts is more along the lines of, 300-400 euro. So I think it's just a matter of time. We didn't buy also the inverter for three-phase that is a hybrid inverter, because the inverter has to be compatible. You could do on-grid and off-grid batteries also, so there's different ways of doing it. Was a lot more expensive, and also wasn't in stock, and I'm impatient. So yeah, I just didn't cost-wise. We would have to, and it's the same with the home installs. My uncle got it installed. He got a 2 kilowatt battery, of which was well over €1,000. And sure, by the time the power is turned off, by the time the solar panels are dead, somebody's come home and turned on the oven, the battery's dead. So it's a false economy. I just don't know why you really have to be buying, 10, 20 kilowatts array for you to be kind of off grid. And to some extent, if I'm a year from now and I know that I've put in, on average, I put 5 kilowatts back into the grid, then I know 5 kilowatt battery is what I need.
All right. Well, thanks again for doing the presentations and answering all of our questions.
Thanks for having us.
All right. Bye. So thanks, folks, for tuning in. You can always watch the talks back, share them with a friend. They're all available on our YouTube channel. Thanks again to the Young Engineers Society for partnering with us for this event. And there's plenty of events still out there for Science Week. Dublin Maker has some great events tomorrow and Saturday featuring TOG members as well. You can find them all on dublinmaker.ie. And check into us, because we've got plenty of virtual events coming up. We have our book clubs, our coding meetups, our Wikipedia editing, and we have a great VR social night coming up in a few weeks' time. So thanks for tuning in, and we'll see you again.